So we're going to talk about reflection. And reflection is also another translation that we do to a function. If we're looking at the notation, we're going to use the notation of negative f of x as a flip across the x-axis. And from geometry, you might look something like this, where here's our x-axis right here, and we're flipping a shape across the x-axis. For notation for flipping across the y-axis, we would use f of negative x. And again, it would look something like this, where we're flipping this shape across the y-axis. But we're going to be flipping a function over the x-axis and y-axis with our reflections. Before we get into how we reflect a function, let's just reflect a point and understand what we're doing. So if we have the point 4, 2, we go over the x-axis 4 points and up 2. That's what that point is. Let's say we want to reflect across the x-axis. Well, all we were going to do is move this point to this place right here. And that is going to be, it's also going to be 4, 2, but our y value has become negative. So that's just what's going to happen with our functions as well. All our y values will be negative when we flip across the x-axis. And let's say we want to reflect this point across the y-axis. Well, we're going to end up right here, right? That's a reflection across this y-axis right here. It's a mirror image. And so that point right there is going to become 4, 2 also, but it's going to be negative 4. So our x value turns negative when we flip across the y-axis, and our y value turns negative when we reflect across the x-axis. So that's kind of what we're after here. So let's talk about this. We're going to have we have our notation for a reflection across the x-axis. So we are going to take negative f of x. And what does that equal? Well, we just put a negative sign in front of the x squared. It's like we're doing this, and then we're just putting a negative sign right there. Okay? So our new function, which we could call, we could call it g of x, or hey, let's spice it up a little bit. We'll call it h of x, is going to be a reflection across the x-axis of f of x, and it's going to be negative x squared. So we're going to talk about what this graph looks like in a minute, but you would expect all the y values to be negative. So for this, though, let's say we want to reflect across the y-axis. We would take the function f of x, and we would negate or make a negative x value. So anywhere where there's an x, we're going to subtract, or we're going to put a negative x. So we write this like this. So anywhere where there's an x, like right here, we're going to write a negative x, but we must put it in parentheses before we do the operation that makes it the function. So let's define this one as m of x is going to be the reflection across the y-axis. Okay? So m of x is going to be negative x squared. Well, guess what? We have to square that. Well, negative x times negative x is going to be equal to x squared. So that's very interesting. We're kind of look exactly like our f of x. So m of x and f of x look the same. Let's go ahead and look at the graphs of the two. So for, what do we call it, g of x, I think it was, our g of x was negative x squared. And our f of x is right here. So our parent function, f of x equals x squared, is in black. And the green one here, we flipped it across the y-axis, and now all those y values are negative. Whereas with this one, you actually, we're seeing f of x, but the funny thing is we know that m of x equals f of x. So you don't see it, but it's actually the same exact function. It's just one on top of the other. All right? So that is the reflection across the x and y axis of a function.